This video will explain the math behind the examples, so that you will gain a greater understanding of why the examples work out. So let's get started now on MathCat. 3, 2, 1. When you have a variable in an equation, like x plus 5 equals 20, in order to find out what the value of x is, we call that solve for x. Solving for x means find a value of x that makes the equation true. What do we mean by making the equation true? Well, an equation means both sides of the equation are equal. See how the word equal is in the word equation? Both sides of the equation have to be equal in order for the equation to be true. In order to solve for x, x has to be on one side of the equation and the numbers on the other side. For example, x equals 15 is a way of solving this equation, because if we put 15 in for x, the original equation would be true. 15 plus 5 equals 20. And if we added 15 and 5, we'd get 20 on this side of the equation and 20 on this side of the equation. So by putting the value of 15 in for x, we've solved the equation. We've made the equation true because it's equal on both sides. How do we solve for x? In our simple equation with addition, we can undo addition with subtraction, or we can undo subtraction with addition. So in a one-step equation, we're going to solve it by undoing addition with subtraction or undoing subtraction with addition. That means if I perform an operation on one side of the equation, I can perform the same operation on the other side of the equation and not change the value of the equation. In order to get x by itself on this side of the equation, I'm going to want to subtract 5 because this adds 5 to x. So I'm going to subtract 5 from this side of the equation. That will leave 0 next to the x. But if I subtract 5 from this side of the equation, to keep the equation true, I'm going to subtract 5 from the other side of the equation. And when I subtract 5 from 20, I get 15. So the equation would look like x plus 0 equals 15. But if we add 0 to any number, we haven't changed the number or the variable. So we can just write x by itself without the plus 0 equals 15. And we've solved the equation for x. Let's look at another example. 22 plus y equals 35. Here, we're adding 22 to the letter y, our variable, and getting 35. In order to solve for y, we're going to want to get y on one side of the equation and all the numbers on the other side of the equation. Well, we're adding 22 to our y. So if we're going to add 22 to the y, to undo the addition, we're going to subtract 22 from this side of the equation. And if we subtract 22 from this side of the equation, to keep the equation true, we're going to subtract 22 from this side of the equation. And 35 minus 22 is 13. So we could write this now as 0 plus y equals 13. But adding 0 to any variable doesn't change the value of the variable. So we'll just drop the 0 plus and write y equals 13. So we've solved the equation for y. Y equals 13. And if we put 13 into our original equation, 22 plus 13 equals 35. It makes the equation true. So y equals 13 solves the equation for y. Let's try x minus 9 equals 22. In order to solve this equation for x, to make the equation true, you can see that we're subtracting 9 from x. So to get x by itself on this side of the equation, we're going to want to undo the subtraction of 9 with the addition of 9 on this side of the equation. And if we add 9 to this side of the equation, we have to add 9 to this side of the equation to keep the equation true. 22 plus 9 is 31. So we could write x plus 0 equals 31, but adding 0 to x doesn't change the value of x. So we'll just write x equals 31, and we've solved the equation for x. And if we put 31 in for x, 31 minus 9 equals 22. So you can see that makes the equation true. So 31 solves the equation for x.